So continuing on the lesson, the next topic here is it's about the component form of a vector, and the idea here it's different from component form. Just saying, like over here on the side, we talked about component form is written like triangle bracket and then the x comma y coordinate. Like that is a component form vector, but because we're in component form where it starts 0, 0, goes to point x, y, the components of the vector. So we have the x component of vector, well, I guess it's vector v because, let me change this. Vector v here, and I know that because we are referring to it here as v. But vector v at 44 magnitude also has components that make it up, the x and the y. That's what we're referring to here. Anyway, so when we talk about this, x is the magnitude of v times cosine of theta. So if you think about it, really what we've done is we've created this right triangle. I'm going to avoid the red since we already have red. So what we're doing is we're saying we take 44 and we want to break it into the x and y components. So to do that, we look at sine of 40 degrees. So that's our angle. And because we've created this right triangle, we can say that the sine of 40 degrees is equal to whatever the y component is over 44. And then if we want to know what is the y component, how much of the 44 is applied in the y direction, we can just multiply both sides by 44 and say y is equal to 44 times sine of 40 degrees. Just a PSA, when you're running these numbers, make sure your calculator is in degree mode. Sometimes we use radian mode, so just be careful on that. Same thing goes for the x component. So how much of this vector 44, vector v, is applied in the x direction only? So we say cosine of 40 degrees. And in our right triangle, cosine is adjacent, so x over 44. So similar. In this case, if we want to know what is the x component, you multiply both sides by 44. And we get cosine 44 cosine of 40 degrees. Knowing what we know from that, we're going to look at our next example. And I have to scooch it down this way. So find the components of vector v. So it's asking the x and y components. This time the angle is 120 degrees and magnitude is 8. So if we leave part visible, what we find is that given the information here, we just rewrite it. So x is equal to the absolute value of v, so just the magnitude, which is 8, times cosine of our angle, same thing, y is 8, except this is sine of our angle, 120. And we run our numbers, that is, well, 120 is one of our reference angles, or well, it's one of the angles from the unit circle, but anyways, cosine, that puts us in the second quadrant, -1/2, so times 8, -4. Sine of 120, also reference to some degree, but not as convenient because it's the square root of 3/2. But if I run that through a calculator, just type it in, and we get 6.928. Again, that's second quadrant, sine's positive. With that information, it says find the component form. Well, it's really, you could write as, we could just say the components are x is -4, y is 6.928. But the proper way to answer a problem like this is to write it in component form. So our x component, comma, y component inside the triangle bracket thing. So let's pump out example 3 here quick too. So the player kicks soccer ball, leaves ground at 44 feet per second. So that's your magnitude, 44, the units of feet per second. The angle from the ground up, you're up 33 degrees from horizontal with the ground. Excuse me. So if we were to draw that, let's see, I'll do it in, if we draw that, we've got our y x-axis. Make it a little bit thin. No, I'll go black. So we kind of have this like ball kicked at 33 degrees here. So we'll label 33, magnitude 44, FPS for feet per second. So part A, sketching the diagram. What else? I guess we could label this our x and our y. Yeah, it's just simple as it is. There you go. B, find the magnitude of the horizontal. So B is really what this whole section is about, finding the magnitude. So again, going back to our equations up here, x and y are equal to the magnitude of the vector and then cosine sine respectively for x and y. We'll come back here. X is equal to the absolute value of the magnitude, so 44 times cosine of the angle. And same thing for y, except it's sine again, 44 sine 33. And we get 36.9. Again, we have our units, feet per second, and y is 24. Well, so we sketched the diagram, that's it. I'm not going to box that in, but find the magnitude of the horizontal and vertical components. So, at this point, it is asking specifically for that. So I would just box it in like this. But again, another acceptable form would be the vector component form, which is 36.9 comma 24 boxed in for our component form. So let's see. End the video here for this section because the next segment's kind of completely different. We're not breaking it into components. We're just doing some addition. So I'll pause the video. We'll start up the next section in a bit here.